This video is brought to you by our amazing supporters over at Patreon. Hey everyone, it's Ben from Board to Bits, and in this video we're going to be kicking off a short series about creating a camera control setup for games where you don't necessarily have direct control over an avatar. These are things like management or tycoon style games, or even tactical and strategy games where you're really having an overarching view of either a civilization or a particular group of characters or units, but you're not, directly controlling them and don't have a camera following around your character, so to speak. So this camera setup is going to have basically three functions in it. The camera is going to be able to move forward, back, left, and right. And part of that is that we're going to want to actually limit the movement to a specific area, like whatever kind of the bounds of the particular level or space are, we're going to want to be able to control that. Then we're going to have a rotate function, which is actually going to be the camera orbiting around a particular point that it's looking at, rather than rotating the camera itself. Lastly, we're going to be able to zoom in and out on this focal point so we can get a close-up view of things or farther away. So part of the structure of this is going to be that we're going to have a camera manager script, but it's actually going to be attached to the focal point and not the camera itself. The camera will then be a child of that focal point with some predetermined offset that we're going to establish on it. And so all the control is going to be through that focal point itself, and we'll see why we're implementing it in that way as we build it. In addition, we have a couple of things that we can decide on. One thing is inputs. Two that obviously spring to mind with a computer are keyboard and mouse inputs, but there could be others that you want to include, or you may not want to have keyboard or mouse inputs. So we're going to specifically build that using an abstract class and events so that we can make it a little bit more modular and use and pick and choose the inputs that we want. Secondly, our camera may be orthographic if we're doing something like a 2D game or an isometric style game, or we could be using the perspective camera, and that's actually going to impact some of the functionality, particularly with how we zoom. So what we're going to do is we're going to build the zoom functionality as a strategy pattern in order to accommodate either of those settings as well. As you can see here, I'm kind of using this basic demo little town that I've built. This is using the Kenny asset packs. I'll include a link to his site below. In addition, you can get access to this starter project if you want to use the project that we're actually using here. I'll include that in the comments or in the description as well. However, if you want to start with your own project or just set up a quick project with a few shapes in a scene, that will work just as well. This is just something to get you started if you'd prefer. And with that, let's dive into building our camera controls. So here we have our basic scene, and really all it is our standard starting camera along with some basic objects that we want to view across this sort of a field. And so what we're going to do is we're going to actually have two kind of objects that are going to kind of comprise our camera setup. There's going to be the input manager and the camera manager. And the input manager is going to feed information into the camera manager for us. So we're going to create two new game objects. I'm going to create an empty and call this one camera focus, and this is going to be what contains our camera manager. It's also going to be the point that the camera is always looking at. And then we're going to create a second game object, and this one is going to be called input manager. And this is going to be what is constantly listening every frame for any of our inputs. I'm actually going to reset the input manager to be at 0, 0, 0, just for cleanliness' sake. And the camera focus, I'm actually going to child the main camera so that the camera focus is the parent of the main camera now, because how we're going to be controlling this again is that the camera focus is going to move around and the main camera is going to follow it. This is going to save us on a lot of our calculations that we have to do. Now for right now, we can kind of see up here that our positioning is kind of arbitrary up here. We're actually going to be controlling this through our script itself. However, if we want to see something similar to what we're going to actually be seeing with the camera, we can simply adjust this to something like 0 on the X. I might make Y about, let's say, 14, or yeah, 14. The Z will put at like -10. And then I'm going to change the Y rotation to 0 and the X rotation to something like maybe 30. And I do want to ensure that my camera is actually positioned, though, at the 0 level on the Y, so that we're looking at the ground level. Okay, with that in place, we need to create a few scripts that we're going to be working with. So I'm going to create a scripts folder, and I'm going to, inside of here, actually create a couple more folders. I'm going to create one for input scripts and one for our zoom scripts. And that's because we're going to be building a few different scripts that we can use for each of those. And so I want to kind of collect them in one place. Now we can start actually putting in our scripts. First one I'm going to do is the camera manager itself. C# script camera manager. And this is the only one that's actually going to exist inside of the scripts folder proper. The other scripts we create are going to be inside of these folders. So for input, I'm going to have an input manager, which is sort of going to be that generic abstract class that we're working with. And I'm also going to create for this video a keyboard input manager. For this video, we're going to focus on the keyboard controls as well as the orthographic camera, and then in a couple of extra videos, I'm going to show how to expand this for mouse controls as well as for the perspective camera. In our zoom folder, we're going to create a C# script called iZoom strategy, as well as a orthographic zoom strategy. Okay, and with all of those, we can actually start coding. Now, we're going to do this not really backwards, but in kind of order of dependencies. I don't want to start writing the camera manager and then have to jump back and start writing, the input manager when we need it, or the zoom strategy when we need it. So I'm going to start with the thing that doesn't depend on anything, which is the input manager. And then we'll do the zoom strategy, and then we'll actually write the camera manager, which is going to depend on both of those. So let's start by opening up the input manager in Visual Studio. And in here, we're going to change a couple of things. We're going to keep this as a mono behavior, but I'm going to make this an abstract class. We're never just going to have a generic input manager. We're going to rely on different types of input managers. And in here, we're going to have 3 delegates, which are going to be sort of what control when we do get an input. It's going to be how we tell the camera manager that an input has happened. And so it's going to be in the format of these delegates. So we're going to have a public delegate void called moveInputHandler. And this is going to take in a vector3 called moveVector. I'm going to have a public delegate void called rotateInputHandler. Takes in a float called rotateAmount. And lastly, a delegate void called zoomInputHandler, which will have a float for the zoom amount. And this is all we need inside of here. We just need these delegates, and then our actual keyboard input manager is going to implement all of these. We can go into our assets and scripts here and open up our keyboard input manager now. And this one is now going to implement kind of the rest of the functionality. So the first thing it's going to do is it is going to inherit from input manager, which means for all intents and purposes, it is an input manager. It just has the extra stuff of the keyboard input manager. I'm going to delete the start function. We're not going to need it. And I'm going to put in here the actual events that are going to use those delegates. So we're going to have a public static event of moveInputHandler called onMoveInput. Public static event called rotateInputHandler, which is going to take an onRotateInput, and one for the zoom as well. OnZoomInput. And so these are what are going to actually be in charge of actually saying, hey, I've taken in this type of input. Here's the information you need to know about it. Everything else is going to happen in our update function. So the first thing we're going to check is, have we pressed buttons to move the camera? In this case, I'm just going to use the WSAD keys. However, you could use whatever key combinations you like. You can also use the actual input buttons using things like the horizontal and vertical axes if you prefer. But for now, it's just a little bit more straightforward. I'm going to say if input.getKey, and take the key code for W. Then we're going to call onMoveInput question mark dot invoke. And what this does is basically says if onMoveInput has some subscribers listening to it, then we're going to call it with these particular parameters. In this case, W, we want to move forward. So we'll say vector3.forward. And it's basically going to be the same for the rest of the directions. We're just going to have a couple of kind of changing the keys and changing the directions that we call. So for S, it's going to be moving backwards. So I'll just say negative vector3.forward. For A, we'll say negative vector3.right. And for D, we'll say just positive vector3.right. So that gives us all of our movement controls. Next, for our rotation, same idea. We're going to use the Q and E buttons for controlling rotation in this case. It kind of keeps everything nice and contained there. Same idea. I'm actually going to copy these two here and simply change the keys that I want. So we'll say E and we'll say Q. And I'll change what we're invoking. Instead of invoking onMoveInput, we'll do onRotateInput. And I'm going to change the amount from a vector3. In this case, we're just taking a float. So for Q, it'll be 1F. Or sorry, for E, it'll be negative 1F. And for Q, it's going to end up being positive 1F. Obviously, these numbers and that are very arbitrary right now. They don't really mean anything. It's when we actually kind of implement the camera manager that this will all be put into motion. Lastly, we'll do the zoom controls, and these work almost exactly like our rotate controls because they actually take floats as well, so I'll simply copy them again. I'll put in some comments here so I remember which are which. And in this case, I'm going to use the Z and the X keys. Again, they're nice and kind of grouped together. Z will be for zooming in, and then X next to it will be for zooming out. And so in this case, we'll do zoom input for both. And we'll keep the Z as -1 and the X as +1. And we'll see why we're zooming in is negative and zooming out is positive in just a few minutes. So that's everything we need for our manager now. Pretty simple. The nice thing is it's all very, this is just doing what it's supposed to be doing, which is just taking in inputs and announcing them. There's not a lot going on here. We want each of our scripts to be fairly simple and then have something else kind of controlling what's happening with it. With that, we can move over, we can close both of these and move over to our zoom method, our zoom classes here. So I'm going to open up iZoom strategy. And in this case, we're actually going to turn this, we're going to delete the monobehavior inheritance, and we're going to change this from a class into an interface. What interfaces do is they let us say, here is a sort of a template that has some key functions that we want to implement somewhere else, but we're not actually going to implement them here. It's kind of like an abstract class, but it doesn't contain any sort of data. So that's why we, in the case of the input manager, it has those properties of these delegates. In this case, we don't have those, so we're just going to use an interface. So here what we're going to do is we're going to have one called void zoom in, And this is going to take in a few parameters. We're going to take in a camera called cam. We're going to take in a float called delta, which is going to help us account for things like both the time.delta time as well as the speed that we want to be zooming. And then a float called near zoom limit. And this is going to basically ensure that we don't zoom in farther than we want to. Likewise, we'll have a void called zoom out. And this is going to take in the camera, a delta again, and then a float called far zoom limit. So again, we don't zoom out farther than we want to. And that's all that our strategy is actually going to hold. Our orthographic zoom strategy is where we're actually going to be kind of controlling the camera. So this is going to inherit from iZoom strategy. It's actually going to implement iZoom strategy. And we'll see that this is going to start yelling at us because we're not actually implementing it. So I'm going to put this in here. And that automatically populates with those two same functions that we had here in iZoom strategy. I'm going to delete start and update. They are actually kind of meaningless inside of something that doesn't inherit from monobehavior. And so to implement zoom in, I am going to say if cam.orthographic size, and the orthographic size is basically the size of the frame when you have the orthographic camera. So basically, if your size is, say, 2, then your camera is going to be 2 times 2 units high, so 4 units high. If it was a size of 5, then it would be 10 units high, 5 times 2. Basically controlling how many units of the world the camera is taking in. So that's really effectively your zoom. And so we're going to say if this is equal to the near zoom limit, meaning we've already zoomed in as far as we can, then we'll simply return. We're not actually going to do this. We don't need to do any calculations, we're already there. Otherwise, we're not yet zoomed in all the way, so we can say cam.orthographic size equals mathf.max of the cam.orthographic size minus delta, or the near zoom limit. So whichever of these is actually higher, which basically says that if we do this math here, the graphic size minus delta, and it's smaller than the near zoom limit, we just want to bump it back up so that it's at that near zoom limit for us. So that just also helps us stay within the bounds that we're going to set for ourselves. Zoom out is going to do pretty much the exact same thing. In fact, I'm going to copy all of this, paste it into here, with a couple minor exceptions. First off, we're going to be adding to the delta, and adding the delta to our orthographic size rather than subtracting, and we need to change both of our near zoom limits to far zoom limits, because in this case, we're trying to stay within the bounds of how far away we can get. Lastly, in here, I'm going to create a constructor, because what's going to happen is how we're going to actually set up this zoom strategy in our manager is we're going to create it at runtime. And so I'm going to create a public orthographic zoom strategy constructor method here. And what this is going to do is this is going to take in a camera called cam again, as well as a float called our starting zoom. And this is just going to help us by basically saying at the very start of the scene, whatever we've set our starting zoom to, we're going to set our camera's orthographic size to that. So we're going to say here cam.orthographic size equals starting zoom. Now, if we want to, we could also pass in the near and far zoom limits and make sure that this starting zoom is bound within them. But for right now, we'll keep it simple and just say that we'll trust that our starting zoom is a legal size and that it can be there. Okay. So with that, we can save that, and both our zoom strategy as well as our input management is ready. Now we can actually dive into creating our camera manager. Close both of these. Open up the camera manager. Camera manager is going to inherit from monobehavior. We're going to attach it to that focal point object. And we're going to have a number. I'm actually going to delete both of these for right now. And then we're going to have a number of variables in here. A lot of our settings are going to go into here. We could eventually put these into, say, a scriptable object, but for now we're just going to keep them directly in the component. So we're going to have a header. I'm going to call this camera positioning. And this is going to have a public vector2 called camera offset. And this is going to be responsible for actually determining, like how I had set the y to 14 and the z to -10. This is going to be kind of where we set those values. I'll set it to that default for now. We'll say new vector2 of 10f and 14f. One thing to note here is that I'm using the x for the horizontal position and the y for the vertical position, but ultimately for the camera itself, this is actually going to be the z position and this is going to be the y position. But it's just a little bit smaller to hold within here, so we're going to use the vector2 with the x and y instead of z and y. In addition, I'm going to have a public float called look at offset. And what this is basically going to do is that when we tell the camera to look at the offset point, we may not want it to look exactly at the ground, because that can sometimes actually be a little bit weird. We may want to raise that up a unit or two. So I'm going to add in this offset here as a variable, and we'll put it at 2 units for now. Next we have our settings for our move controls. And these are really just speeds for our motion. So we're going to have a public float called in-out speed. This is going to be how fast we move forward and backward. Default that at 5. We'll have a public float called lateral speed for left and right movement. We'll also put that at 5. You could use the same for both of these, but I find sometimes it's helpful to be able to actually manipulate them individually. So we'll keep them as 2 separate ones. And I'll do a public float called rotate speed in here as well. And I'll set that to 45. Next, we're going to use our movement bounds. So we'll say header. And this is going to control where our focal point can actually move. So I'm going to use 2 vector2s here. One is going to be the min bounds, and the other will be the max bounds. You could also do this with a rect, where you would set the minimum corner and then choose the width and the height, but I find that it's a little bit easier to actually look at, like, say, the minimum corner that you want and the maximum corner and set it up that way. Lastly, we'll do our zoom controls. And these are going to be a public float called our zoom speed. We'll default that to 4. We're going to have a public float called zoom near zoom limit. And a far zoom limit, similar to what we have in our zoom strategy. This is actually what's going to be passed in to the strategy when we call it. And then a public float for the starting zoom level, so that when we do initialize that zoom strategy, it can set the zoom for us. In addition, I'm going to have a couple of private variables. The first one will be that iZoom strategy. And so that eventually will either be an orthographic or perspective strategy. For now, it's just going to be the orthographic, but that's why we're keeping it as the interface, is so that we could populate it with either and it will work. Then we're also going to have a vector3 called frame move, and this is going to be responsible for kind of collecting, if we have multiple movement inputs on a frame, it'll collect all of those, and then we can use that to move. Likewise, we'll have a frame rotate, which is going to collect any rotation information, and a frame zoom for the zoom information. Lastly, we'll have a private reference to our camera, so that we can access that when we need to for things like passing into the zoom strategy. Now we can start actually implementing our methods. So the first one we're going to do is the awake method. Void awake. And in here, we're going to do a few things. First thing we're going to do is we're going to say cam equals get component in children camera. And so that's going to get our camera that we are wanting to use. Next, we're going to position the camera based on our offset. So we're going to say cam.transform.local position equals a new vector 3, which is going to be 0 on the x-axis, math absolute of our camera offset dot y. This just ensures that our camera is positive. If for some reason you want a camera that can go negative, you can just keep it as camera offset dot y and don't include the absolute function. But I just like to be sure that it's going to appear above the ground so that we don't have some really weird effects. And then lastly, a negative mathf.absolute camera offset dot x for our z value. Remember that the x here is just because it's the horizontal value of the offset. And then we're making this one negative so that basically the camera is negative on the z-axis, so that's when it's facing forward, it's facing towards 0, toward the focal point. Next, we're going to assign to our zoom strategy. So we'll say zoom strategy equals new orthographic zoom strategy, and we're going to pass in the camera that we just found, as well as our starting zoom level that we've established up here or in the editor. And that'll set all that up for us. And then finally, we're going to say cam.transform.lookAt, and it's going to look at the focal point's position, transform.position, the world position of it, plus vector3.up times our look at offset. And so that's where, again, we're kind of looking, in this case, right now, we've got it set to 2. So we're going to be looking 2 units above where the actual focal point is, which again just gives you a little bit more of a natural look rather than looking directly at the ground or at like the feet or wheels of a unit. Okay. The next thing we need to do is we need to actually listen for the events of our input manager. And we're going to do this inside of an onEnable method. And we're going to do an onEnable and a disable method so that we can kind of subscribe and unsubscribe to these as we go. The reason we do this is because if we change scenes and this camera manager ceases to exist, we don't want it to remain subscribed to things that may persist, because then what will happen is if it tries to let the camera manager know and that camera manager has been destroyed at the end of a scene, that's actually going to cause problems for our game. So we're going to call void onEnable, and in here we're going to listen to keyboard input manager dot on move input, and we're going to add to it a new method. Now, automatically, if you hit tab, when you do plus equals and then hit tab here, it will populate that with basically this name again. I'm going to change it slightly just because I want it to be a little bit more informative of what it's actually doing. So I'm going to say update frame move. We can do the same thing with both of the zoom and the rotate inputs as well. So we'll say keyboard input manager dot on rotate input plus equals tab, and I'm going to rename this one to update frame rotate. And then finally keyboard input manager dot on zoom input plus equals update frame zoom. Hey everyone, it's Ben from Board to Bits, and I just realized as I was making the next video in this series that I never actually added in the onDisable method to the camera manager. So you're going to want to be sure that when you add in, and when you're doing the onEnable and you're subscribing to all of these input manager events, you also want to have a similar onDisable method that puts in the unsubscribe kind of commands to each of those methods. So basically, the biggest purpose of this is that if you end a scene and say your camera manager is destroyed, the input managers don't think that this camera manager still exists and is listening. So you just want to be sure that you do, it's like I say, it's pretty much the exact same commands here. It's just you're doing minus equals instead of plus equals on each of the update methods. So that's just that quick update, and I'll let you get back to the video. With each of these created, I'm actually going to reorder these just because it's kind of nice to have these all in the same order as how they're going to be executed. And in each of these cases, all I'm going to be doing is adding whatever this input is, this parameter is, to our frame variables. So for update frame move plus equals move vector. For frame zoom plus equals zoom amount. Somehow I got these still switched up. There we go. And for update frame rotate plus equals rotate amount. Now the next thing we're going to do in here is we're going to call late update. And the reason we're calling late update is we want to make sure that our input managers have time to gather all of the input information during the update phase of the frame. And so then late update, we know will happen after all that input is gathered, and then we can use it here to move the camera manager. So we'll say void late update. And the first thing we're going to check is if frame move does not equal vector3.0. If it's 0, we're not moving anywhere, we don't need to do anything. But if it is not 0, then we know that there are some moves to be made. So what we're going to do is we're going to actually modify this based on our speed. So we're going to say vector3 speed mod frame move. It's kind of a clunky name, but kind of gives us the idea. It's basically our original frame move modified by our speed settings is a new vector3, which is our frame move.x times our lateral speed. Frame move.y, we don't really have a speed for that. It should always be 0 at this point, but just in case. And frame move.z times our in-out speed. And then we can simply adjust the position. So transform dot position, and we're moving the focal point because remember the camera is going to move with it because it's a child of the focal point. So we'll say transform equal position plus equals transform dot transform direction. And what this basically does is it's going to basically translate this speed mod frame move from a generic kind of vector3 based on the global world axes specific to what our current rotation is, so that if we're, say, turned 45 degrees, left and right mean left and right to us, not to the world. So we'll say transform direction, speed mod frame move, times time dot delta time. Lastly, we need to make sure that every frame, if vector3 isn't 0, we're resetting it to 0 so that if we let go of a movement key, we don't continue floating off in that direction. So we'll say frame move equals vector3.0. The other thing we want to do with the movement is we want to make sure that we're staying within those bounds that we set for ourselves. So what we're going to do is we're actually going to go back up to just before we set frame move to 0, and we're going to be sure that we kind of lock our position. And we're going to do this with a new method. Say lock position in bounds. It's going to yell at us because we haven't actually created this. But what we can do is generate the method for ourselves. Put it down here. And all that this is going to say is basically once we've moved our position, just ensure that it's within the bounds, and if it's not, we'll move it to that position. So we'll say transform dot position equals a new vector3, which is going to be equal to mathf.clamp transform.position.x between our minbounds.x and our maxbounds.x. And so that's just going to ensure that we're between our kind of left and right boundaries. Transform.position.y is not going to change. And then mathf.clamp transform.position.y minbounds.y. Whoops, sorry, this one should be z. We want to keep this as our z position, but then minbounds and maxbounds, because they're vector 2s, will be .y. Maxbounds.y. Okay. Oops. Y. And there we go. Okay. And so then we're calling that lock position in bounds and then zeroing out the frame move. Rotation is fairly easy as well. We'll say if frame rotate does not equal 0, because this one, remember, is just a float. If it's not 0, then we have some amount we want to be rotating by. And so we'll say transform.rotate. And we're going to rotate on the y-axis, so we're going to say vector3.up to get that y-axis. And the angle we want to rotate at is frame rotate multiplied by time.delta time multiplied by our rotate speed. Lastly, for frame zoom, we have to do this a little bit differently in that we can't just check if it's not equal to 0. We need to first see if it's less than or greater than, because that's going to tell us if we're zooming in or out. So we're going to say if frame zoom is less than 0f, then we know that we're zooming in. And so we can call zoom strategy dot zoom in, and we'll pass in the camera. We'll pass in for delta, we'll pass in time.delta time times mathf.absolute of our frame zoom, because at this point we do want to actually pass in a positive number, because now at this point we know we're zooming in, and we just need to know the amount we're zooming in. So we're going to make that a positive value at this point and multiply that by the zoom speed. We also need to pass in our near zoom limit to control how far we zoom in. Otherwise, we need to check if our frame zoom is greater than 0. So we'll say else if frame zoom is greater than 0. Oops. Close our parentheses first. And we're basically doing the same thing. I'm going to copy this, paste it here, but we're going to do zoom out. And in this case, we don't actually need, because the zoom we know is positive, in this case, we don't need to get the absolute value of it, so we can save that step. But otherwise, the only other thing we need to do is change this to pass in the far zoom limit to ensure that we're not zooming out farther than we want to. And in both of these cases, we also need to make sure, whether we're zooming in or we're zooming out, that we set our frame zoom equal to 0. And I just noticed as well that we need to make sure that we reset our rotation, or frame rotate equal to 0 after we rotate as well. And this again is just so that when we let go of the key, it zeroes out and we're not rotating indefinitely. Okay, so with those in place, we can now jump back to Unity and actually set up the rest of the components that we need. So in our input manager, I'm going to go add component, and I'm going to add in the keyboard input manager component here. We don't have any settings we need to worry about there. Camera has everything it needs at this point. On the camera focus, we are going to do add component and put in our camera manager. Now the only thing we need to make sure that we control here is our move bounds, because we haven't set those yet. And an easy way to actually determine what you want your move bounds to be is to actually move your camera focus around and see kind of like what the limit is that you want to be moving. So right now, for example, if I grab this and move it down here, for example, I can see that that's at about a position of -15 and -2. So that's probably my lower bounds that I want. So I can say here -2 and -15. And then if I move it all the way up here, about probably as far to the upper right as I would want, that's 33 and 29. So I can put those into my maximum bounds. And that will inform now how far the camera can actually move. I'll kind of position this again a little bit better centered here. And with all of those in place, we should now have a functioning camera controller. Let's hit play and see what happens. So our camera repositioned itself a little bit, and now we should be able to, press the keyboard buttons, and we're getting movement around our scene. Right now, we have no rotation, and we are looking kind of straight on to everything, which makes sense here. So now if I hit Q, I start rotating counterclockwise around the world, and if I hit E, I start rotating clockwise around. And I should be able to as well zoom. Something's being a little funny there with the zoom out. I'm guessing that I've got something off a little bit in my near and far zoom, so I'll double check that in just a second. But, in fact, I think I know exactly what it is. But overall, that is working pretty well. So that one bug there is in our zoom strategy itself. So if I go to my orthographic zoom strategy, the problem is that when I'm zooming out, I'm still taking the max. So what's happening is even when I'm not at the far zoom limit, it automatically snaps to this. I want this to be the min, so that once it exceeds the far zoom limit, it goes back to it. That should fix that. Jump back over to Unity, hit play again. And we can see now that we zoom out and stop there. So that's working as intended now as well. So that gives us our functioning camera control system. Right now we're focused just on the orthographic controls as well as the keyboard controls, but in future videos we're going to add in mouse controls as well as how this will work with a perspective camera, which really in both of those cases is just updating a single script, whether that's the input manager script specified to the mouse controls or creating a new zoom strategy specified for a perspective camera. In the meantime, thank you for watching. As always, like and subscribe, and consider becoming a Patreon supporter if you want to support more videos like these. I hope you found this helpful, and I'll see you next time.